Glenn Morris from the Smart Energy Lab again here. Well, a few weeks ago, I had a wonderful podcast with a bunch of mates. I had Michael and Vincenzo from Canadian Solar and Sean from Clenergy. And we just kind of rambled about the industry. A bit tech, a bit kind of gossipy. Anyway, that's what it's up for today. So let's just check it out. The podcast with Michael and Vincenzo from Canadian Solar and Sean from Clenergy. Okay, with Vincenzo and Michael from Canadian Solar and Sean from Clenergy. We've had some fun today and we're going to just have a bit of a chat about the industry and what we're up to. So yeah, let's get into it.
Actually, Glenn, what is the history of this place?
Yeah, well, it was founded by 12 families back in 1974 who lived in Melbourne, who were kind of looking at alternative ways of living. And they tried all living together in the city, in houses next to each other, a bit like the Beatles did. And it was just too difficult in an urban environment. So they started looking for a rural location near to Melbourne. And they found this place. It was founded in 1974. It's been, from my perspective, off-grid ever since then. So we're an intentional community, which means we just intend to live together. We've got quite a lot of structure around that. We're probably one of the oldest intentional communities in Australia.
Okay. And it seems like there's a big shift towards, I guess, sustainability in intentional communities. Is that right?
You could say there's been different moods or movements throughout that period. I think initially it was all about social experiment, alternatives to how to live. There was some experiment with, let's just be like a commune and all share our income. That didn't last long. The lazy ones were looked down on. So it then became just really a lot of separate families who live collectively, share a lot of resources, including energy. So that's one of the things that we've really moved along with, which is how do we share energy on an off-grid community?
Yeah, okay. And have you lived in this sort of lifestyle your whole life? Did you grow up in intentional communities, or is this something that you were moved towards as you got a little bit older?
Actually, no. This is the first intentional community I've actually lived on. As a kind of teenager, I've visited a few and hung out just for fun. But that's the first one I lived on. I think for me, the move was about family. I was wanting to start a family, and I thought it would be a great place to raise kids, which it has been.
Okay, excellent. I spent a bit of time on an intentional community myself, actually. I think I mentioned that to you earlier in the day today. And it was great. It was actually, the one that I was on was really built around permaculture as a practice. I'm sure you're probably familiar with that. Up in the hills of beautiful Byron Bay. Had a lot of fun in that area, actually. So, but as Michael was saying, we're out here today. We're doing a bit of filming. We're installing some Canadian solar panels on the roof of one of the facilities out here. Also on top of our new commercial tilt system. And we did a bit of filming and testing of the new universal clamps today, which was a bit of fun. I won't expose too much about that just yet. I'd like to just sort of expand on what you were talking about there, Glenn, and then ask the same question of you guys, Michael and Vincenzo, about Canadian Solar and their beginnings. So SolarQuip, can you tell me a bit about SolarQuip? Was it founded here, or was it something you brought here with you? Or
both, actually. It sort of was founded while I was driving from Sydney to Melbourne to live here in 2003. So I'm driving along. Well, my partner at the time was driving and I was in the passenger seat, and I was trying to think up a name for my company that I wanted to start when I arrived, and came up with SolarQuip. But really, the backstory is that I've lived off-grid since 1991. And I started doing a little bit of solar installation work for myself and then my neighbors and a few friends. And it wasn't until I came here I realized actually there's quite a big market for off-grid. So it was all about off-grid initially. So SolarQuip really was an off-grid installation business. Then I think it was the 8th of May, 2007, I think it was, with the budget announcement of the $8,000 rebate, the whole market exploded. It was all about on-grid. Grid-connected solar. And so that's where I moved to, was doing a lot of grid connect. But in the last 5 years or so, I've moved just into training. So all I do is training and consultancy here at the Smart Energy Lab, which is my facility. And there's been a bit of a change in the way that's been delivered too. I think this is something that you've noticed, that I used to do a lot of face-to-face training, but what I'm doing now is all online.
Okay, and so originally off-grid, and then there was a big shift to on-grid. What does it look like these days? Is it still, I mean, obviously it's still prominently on-grid solar, but is there a bit of a movement back towards off-grid these days that you're noticing at all? Or?
Well, certainly in this area, there's a lot of what we call fringe of grid. So the new builds in a rural area, there's power in the street, and the customer gets a quote to get power put on $30,000-$40,000 to your front door, not even that, to the front of your paddock. And by the time you've paid for all the infrastructure to get power to a switchboard on your home, you're up for $50,000-$60,000. Now that's a budget that you can compete with a good quality standalone power system. So now off-grid is directly competing with on-grid in fringe of grid areas. The other area that's really exciting too is where there's capacity constraints. So I've had a customer, for instance, who had a big home. They're using linear 200 kilowatt hours a day. They're on a swirl line, and a swirl line is like really capacity limited. So they had 10 kVA per phase. They just wanted more power, and they got a quote for $600,000 to upgrade the lines to their home. So there was the budget. I can remember the pitch, Glenn, there's your budget. And I said $599 comes to mind. So actually we could do a much bigger system. So, 46 kilowatts of solar, 300 kilowatt hours of batteries, and say goodbye to the grid.
Just on that, Glenn, what in God's earth were they doing that they needed 200 kilowatts per day? I mean, what's going on?
Don't ask.
What was it? A colony of sunbeds or something?
There was actually two people, so it wasn't just one person. There was two people in the house, and they did have a son who occasionally would visit. So I was told to budget another 30 kilowatt hours for when the son comes to stay. And when you walk in the house, you realise it was a big house. So it was, I think there was 10 split systems in the home, 3 stories high, full-sized underground bowling alley. Massive
impressive.
garage for all the Ferraris and things. Yeah, so they used a lot of energy.
Right.
Yep.
Okay.
And Michael and Vincenzo from Canadian Solar. I'm really keen to hear about the backstory of Canadian Solar, how it was founded, and how you got to where you are today.
Okay. Vince, why don't you do the foundation story?
Yes, I think the foundation, Canadian Solar is now 20 years, was founded in 2001. And it happened that back in the days, Volkswagen, the large car manufacturer, had an issue, was running an issue. All the battery of the car, the new car, were running flat.
And that was in Canada, wasn't it, when they were storing cars?
Yes, in North America in general.
Yeah. Okay.
So, but also it was a generic problem in Europe, where Volkswagen is the largest car manufacturer in the world. And they issued a tender for a solar panel manufacturer, asking to solve their problem, to keep up the battery, the car battery, while they were storing the cars, parking the car, essentially. And most of the manufacturer come up with their standard solution, back in the days, probably, Glenn would remind, it would have cost like $1,000 for a panel, $1,000 for a panel, for a 100 watt panel. So at the time, our chairman, Sean Coop, he was a PhD student in Canada, and they participated to the tender, and they designed a special small cell solar panel with 4 vents that was attached inside on the windscreen, and then was back fitting through the cigarette lighter the battery. And they essentially won the tender. And then in a couple of days, they had to come up with a name for a company. And that's Canadian Solar story. That's it.
Okay, so the batteries going flat, was that an issue just after manufacturing and then they would sit there for a while? Or was that just after you'd sell the cars and people would own them and they'd sit them there for too long?
Yeah, while the car were sitting in the parking waiting to be delivered, sold worldwide or North America.
So then they'd remove these from the cars.
Then they were removed, and then there was this cooperation within Canadian Solar and Volkswagen, and so Volkswagen helped Canadian Solar really back in the days, and they achieved all the certifications in Germany, and off they go. They went. Yes.
That's a cool story.
Yeah, that's a really cool story, and I think is inspirational for everyone. I mean, who wants to start the business like SolarQuip, probably. Yeah.
Yeah. And Michael, how about now? Like, can you tell me a bit about the Australian team?
So 20 years on, I mean, we've been in Australia for 7 years, since around 2014. I think we're more than 50 people across the company here locally. So that's a point that's often missed by people. Just the number of local staff we have. Not just supporting across the module business, but we also have our energy group out here as well that are involved in greenfield site development and that sort of thing.
Okay.
Along with the MSS side, which is module systems and solutions that Vincenzo and I belong to, that look after supplying modules out to the residential market, C&I, and also the utility space. So, it's certainly come a long way from the early days of Sean whacking a few solar cells on the inside of a windscreen in Volkswagen cars, but that was a very fortuitous moment. So it helped with him getting certification of his module and then being able to leapfrog into the German market very early when Grid Connect took off over there. So
yeah. I can imagine. And so was that obviously so it started in Canada?
Yeah.
Okay. And then picked up some steam in Germany from there? Or?
Yep.
Okay.
So the German market being the first, decent market that was established in terms of Grid Connect. So they had the manufacturing plant in Canada, and they were able to supply out of there. And obviously, as the market boomed, they looked at other manufacturing opportunities around the globe as well. So now we have, I can't remember the total number of manufacturing facilities we have now.
No, we have many, but we have a manufacturing sites in Brazil, in Canada, in Thailand, in Vietnam, of course, in China. We got our cells. There are manufacturing sites. Philippines, we have probably more than 20 manufacturing sites. So,
well, it's a lot of manufacturing sites. Is that normal for panel companies to have that many sites?
Probably, we also need to. And there are also a strategic and political reason why sometimes you also need to have manufacturing sites.
Sure.
Like Brazil, as a developing country, they have a high feeding custom duty, on everything is important. So sometimes you need to build your manufacturing facility locally to compete in the market. It depends. Yeah.
Okay.
So depends. Strategic. Yeah.
And so, did you say the US? There was a site there as well, or?
And no, in US we don't have a site, and we have US. We're feeding US from the talent factory for other political reasons, probably. But,
Okay.
The tariffs. Tariffs are well understood there at the moment. So
yeah, fair enough. And sorry, just to step back to what you said earlier, Michael. 50 people in Australia. That's a lot.
It is.
I'm very impressed with that. Like, what's the breakup between sort of the panel sales and distribution side compared to the project side?
Oh, you've got me there, Sean. But I would think it's probably in the range of a 50-50 split across both. Yeah. Because we assist them in terms of our administrative and logistics team, obviously help out because we're supplying our modules into those energy group projects, of course. So they utilize that way. And then we also, we have our own internal legal teams and things like that. So they work across both sides of the business. So there's economies when you've got, those differing segments that you're addressing. But it's just great. It makes us a pretty strong self-contained unit in terms of being able to respond to customer requirements in the market and that sort of thing. We can most of the time resolve things locally. Of course, we still rely on headquarters quite a lot as well, particularly on the R&D side and things like that if we get any curly questions. But most of the time we can resolve a lot of it locally. So it's great.
Okay. And is that all? Are they all based in a centralised location in Australia? Or
no, we're pretty disparate. And like everyone over the last 12 months, we've been more disparate. But our main office is in Melbourne, in Richmond, or Cremorne, as they like to call it these days.
Yep.
But we have a small office in New South Wales, in Sydney, and also in Brisbane and in Toowoomba in Brisbane as well. So I guess we're a bit spread out.
I guess us ourselves, we don't have quite as many as you in Australia. I think it's around about 30 to 35 staff at the moment. But
wow. Fair numbers.
COVID certainly, you know, we just signed a lease on a brand new facility. I think, just prior to,
and we're all wrestling
March.
with that, right?
And then there was the work
dead
from
money
home
and rent. Yeah.
How did that go for all you guys? I mean, like, did COVID for you, Glenn? Was that one of the reasons you went to like online training?
Very much so.
Okay.
So I basically was kind of delaying running face-to-face courses for the first few months, and then I realized it wasn't going to happen once borders closed, because I get students internationally. Maybe 10% of my students are from overseas. They couldn't come here, and then the internal borders was a big problem because probably more than 50% of my students are from other states. So I just had to think, well, what can I do? And I started doing online training. Actually, for me, it's been really good. So COVID forced me to think about my business in a different way, which is how do I provide quality content and still have that intimacy of talking to people, because really that's what they want. It's just not, just do this training package and you're compliant. It's about, eye-to-eye contact, answering questions, the socialization of meeting people and building a learning community. So often with my courses, particularly the longer ones, the 5-day courses, they become friends on the course, and they're all sitting there in a Zoom session, 4 hours every morning, talking to each other. I rock up at sort of, 8 o'clock and they're all talking to each other and go, oh, right. Yeah, things have started already. It's been fun. So I call it walk to work, 10 meters.
That's really interesting. Actually, I hadn't even thought about that. So they can log in before you arrive to start the training for the day.
Yeah,
it's just like a normal course, I suppose, but it's all done on Zoom. And they could be anywhere in the world, and then they establish these friendships.
Yeah, like on my last course, a guy from Ghana, a guy from South Africa, New Zealand, and a bunch of Aussies. And and they all had different backgrounds and skill sets, and so they were sharing a lot of information in the breaks. So we'd have a half-hour break in middle of each session, and they'd be just staying there talking to each other. So it was very much like the social atmosphere of a classroom.
That's it's fascinating. I didn't realize up like 10% or more of people weren't even in Australia on these courses. Like, so is a lot of that driven by the online content that you create at all, or have you, like, you've got your YouTube channel now, and I'm a subscriber, just so you know. and I sit there and I watch the videos. A lot of it, most of it, to be honest, goes right over my head. I know all about racking, but I don't know too much about inverters or panels. Tell me about the journey, because I mean, as far as I'm concerned, you do it better than anyone else in the industry. And you've just given us a tour. You've got 3 studios now, it looks like. And you've certainly got all the gear, and you've got an idea. So can you tell me, how did that all start?
Yeah, I call it a virtuous circle, which is there's suppliers of equipment, there's students, and there's me, the trainer. And I come up by accident with a solution for all 3, which is companies supply them with product, which gives exposure of their product in a non-sales environment to students and who get to learn stuff. And for me, I get to learn stuff because there's no better way about knowing a product than installing it, playing with it. And I actually live with it. Like, my house actually has 4 circuits from my labs. I run my house on different systems quite often. So my kids were going, the TV's not working. Oh, we're just switching over to a new inverter. So I get to know.
We're switching back.
That's right, we're switching back. That's right. So we do have a few little outages during classes. But I get to understand that stuff. And for product suppliers, not just exposure of their product in a non-sales environment to my students, but also I give a lot of feedback because I'm on the standards committee, so I can give a standards perspective of the products and understanding how it complies, particularly new players entering the market. What are the standards they need to consider? So I call it a virtuous circle.
Okay, cool. And you do work a little bit with the Smart Energy Council?
Yep. I used to be the vice president for 6 years.
Okay.
That was enough. It's quite a lot of commitment, being on a board. But now I just do, webinars and training sessions for them here and there. Yep. So they're a great organization.
Okay, cool.
Yep.
Actually, you mentioned that you got quite a few products from many different manufacturers here, and I think I heard. Did I hear correctly, guys, that Canadians releasing an inverter?
Yeah.
We are releasing an inverter. A lot of people is surprised probably, but they probably don't know that, and I was explaining to Len before, in South America, we are the inverter market leader, and everyone else is coming behind Canadian Solar. So Sean Q again, he decided to tell us the way to go. So he want Canadian Solar to be a one-stop technology provider. So we would like to provide the inverter and a module. So we're coming with this new 5 kilowatt inverter, and we are also, this is the generation 3. So we are already the 3rd generation. And also we are working on large utility scale inverters as well. Yeah.
So, yeah, I mean, the advantage for us, I guess, is because we understand the module technology side of things. We know where that's going in terms of the technology roadmap and development. So we can ensure that our inverters, go hand in glove with the products we're producing, and also taking the feedback of the market. I mean, it's, the inverter market's a well-developed market. We know we're entering in a pretty competitive space, but, the technology we understand, power electronics is well understood. There's a lot of good power electronics engineers out there. We've built up a formidable team. We've got a manufacturing line in China, and we believe it's a great product. So it'll be exciting to step into that side of it as well, and not just have the conversation about modules and monocrystalline and polycrystalline and all the various nuances of modules. We'll be able to talk inverters as well.
Yeah,
Michael, I guess it means you've also got 50 staff here in Australia who can support the product. I mean, not all of them, but it's not like you just have to suddenly invent a support system because you don't have any staff
No,
here.
exactly. That's bang on, Glenn. But it's, I mean, as a manufacturer, you have the luxury, if you've only got one product, to stand back and observe other elements of the market. So we've been fortunate that we've had a lot of time to look at that, and we still work with all the inverter manufacturers in various ways in terms of products we're bringing to market to ensure compatibility and that sort of thing. But we sort of thought, well, why don't we make it a bit simpler for people? And then you've got a unified brand across modules and inverters as well. So there's some upside there, and maybe that works better for the consumer. We'll see. But yeah, we're excited about it. It's going to be a fun year.
Michael, I could just reflect on something I've noticed a lot with inverters coming to my lab. A lot of them don't realize that panel currents have gone up. They've gone over 10 amps. And that's a magic number because many of them had a 12.5 amp maximum short circuit current. And once you go over 10 amps and you apply the 1.25 times overload capacity requirement of our standard, that's not enough. You're going to be more than 12.5 amps. And so they're going, oh yeah, but the panels don't put out more 12.5. Overload capacity, it's part of the standard. So yeah, they're getting caught out by not understanding the integration of the module to the inverter.
Yeah, absolutely. And as we see, I mean, I can't remember a time when power classes of modules have increased so rapidly in such a short space of time. I mean, from what we see, the default for residential now is around a 370 watt, mono PERC product, which, you only went back a few years ago and where it was 300 watts was sort of the benchmark, or maybe 315. So, things are increasing pretty dramatically. I mean, more dramatically probably at the utility scale, and Vince can probably talk more about some of the exciting things there. But, the module space is evolving far more rapidly than it used to. And I think it's just the investment of the major players in terms of R&D and, technology that's coming out of facilities like UNSW. I mean, PERC technology came out of there all those years ago, and PERC's just a standard thing these days. It's not really thought about, but it was pretty significant at the time when it was first developed, and now it's just passé.
Sean, can I do another follow-up?
Please. It's a conversation after all, so
look,
give me a break.
Look, maybe this is a little controversial, but look, if we got rid of the CEC silly rule of the 133% maximum oversizing, we'd unlock a lot more potential on people's homes. Because, look, I'm embarrassed by this, but actually I was on the committee that helped write that rule way back when it was really about maximizing yield of a panel. We didn't want 1 watt to go to waste on the most perfect day of the year. But the reality is every day isn't a perfect day. You might not live in a place that's cool enough to get there.
Mhm.
So chances are that oversizing will give you more renewable energy on the existing hardware limits that you have, because the utility limits are the stopgap. They say 5 kilowatts maximum or 5 kilowatts export. You're locked in at that.
And the dynamics were very different. If you went back a number of years, the cost of a module was, almost 10 times what it is today. So it's, things, I mean, the technology moves very rapidly, and that's always the challenge for standards committees, right? That, the technology gets ahead of the standards, and so there's always a lag and a catch-up. So
Can I just defend that there wasn't anything to do with standards? That was the CEC guidelines.
Okay, right.
Standards never said any limits on capacity. It's just manufacturer's recommendation.
Mm-hmm.
Yep. I came across that clause of the CEC installation guidelines, and I couldn't really understand as an Italian. I said, why they are limiting the inverter to have only 33% of capacity above the. I didn't understand that. I just stick to it.
So as Michael pointed out, it was when panels were very expensive, and it was. By the way, it wasn't enforceable when it was written. It was just a guideline for the industry that to get maximum yield, i.e. no watts would not be produced, that was a good match. In fact, it used to be, the wording was the inverter's output capacity should be at least 80% of the peak watts of the array. It got changed to 75% of the peak watts of the array, which if you do the inverse is 133.3%.
Yeah.
Legacy issues.
A legacy issue. Yep, unfortunately, it gets locked in with STCs. But of course, once you get out of STC land or you add a battery, that's the other get out of jail free clause, because the CEC guidelines only apply to grid connected systems without batteries.
Once again, this is like when I watch the SolarQuip, Glenn's episodes, all this goes straight over my head. It's
Sean, we have to do a Toolbox Tech Talk.
I think so.
And we have to focus on something I don't know a lot about, which is racking systems. So I'll bring the experts in from Clenergy and we'll knock it out.
Yeah, let's do that. We could do that. And then maybe I can come and attend one of your courses and brush up on my CEC guidelines and why they're...
Why they're silly.
Why they're silly, okay, yeah.
They're not all silly. Just that particular rule I think silly. But anyway, there you
go. Michael, you kind of alluded to that Vincenzo might be able to talk a little bit about some new technologies that are coming out for 2021, which I'm really keen to hear about from you guys as well as you, Glenn, as well. What's happening this year?
What's happening this year? Well, there are big disruption happening in the industry, I would say. For the last probably 10 years, we've seen only 156 millimeter cells, and then bang, we are at 166, 180, 210. A lot of R&D was a lot of expenditure in R&D from the largest manufacturer, and we got here. So Canadian Solar in the utility space is this year is bringing the 650, and they will go up to 680 by Q4 2021, which is unbelievable. And yes, it's really exciting. I think that the product is really can be a game changer, the Canadian Solar product. I really believe that. Canadian Solar already in the past, in 2015, was the first company to have the double glass bifacial, the diamond. Was the first to introduce the 166 millimeter cell, and in 2020 we brought into the market the 180 in conjunction with Jinko and Longi.
Vincenzo, I've got some here.
Yeah, really?
That's in the kitchen there.
What?
The actual cells.
I'm keen to see it.
Yeah.
Just while Glenn's grabbing that, you guys got any? And I'm having a little dig at you guys right now, but also at every other panel manufacturer out there. Just every so often, pick up the phone, let us know that the panels are getting a little bit bigger or a little bit thinner, just for our stock control.
So hold the presses, Sean. We've got an announcement. We are moving to a 35 millimeter frame on our 370
and you're 40 at the
watt
moment,
module.
right?
We're 40.
Okay,
yeah.
I can deal with 35s.
Good,
That's all right.
good. I was hoping we don't have
you.
to change too much in terms of
that's very kind
the fine
of you,
Clenergy product, which is good. Yeah,
that's great.
So it just means we obviously get more modules in a container, which is more efficient for everyone concerned. So and we don't sort of sacrifice too much in terms of our wind loading. I mean, we're doing wind testing at the moment anyway, Vince, aren't we, in terms of cyclonic testing and certification.
Yes.
So we're big on that and having all the regions covered. So
yes, we're testing that. It's unbelievable that a year ago or 2 years ago we were fighting with which one was better between the poly and the mono, and suddenly the discussion moved on which has the bigger cell probably.
So there's no clear winner in the end on that one? Or?
Well,
it's all about size.
It's like a
It's
religious
about
argument,
size.
really, isn't it? I mean, it's there's no mono, poly.
Yeah.
Same. The cell size is the new religious argument, though, isn't it?
Absolutely. I think that the R&D is driving down the cost of mono a lot in a way that that became more and more compatible in terms of cost of the poly and the mono, and also Canadian Solar is also investing a lot more in mono technology at the moment.
But we're relatively technology agnostic. We still produce poly, and we will continue. Sean Q, our founder, who's a material scientist, believe that the development side of poly still has a long way to run. So there's a lot more efficiency that can be gained there. And if we look at certainly in the utility space, the projects, not just here in Australia, but globally, the vast majority of those, if not all of the recent ones I'm thinking of the last couple of years, have all been poly. And that's just simply comes down to LCOE. It works out better.
Yeah, correct.
It works out more cost effective in the returns for investors. So, don't write off poly. It's been done before. It'll be done again, but it's still with us, and it'll still be with us for a long time. So, yeah.
Can I ask a question coming back to the bifacial? So was this developed as a bifacial cell?
This specific, I'm not sure, but now all the cells coming from the manufacturing sites are bifacial cells, no matter whether they are going into a bifacial module or in a monofacial module. So the monofacial modules, that known as a PERC, they got a kind, let's say, simplistically, they got a kind of a reflective back sheet. So when the light hits the cell, some of the light is bounced, some of the light is converted into energy, and some of the light is going through the cell, and then is bouncing on the back sheet and is hitting the back side of the cell, which is bifacial, and is increasing the production. So probably, but this is for monofacial. So for the bifacial instead, the light is going through, or the back side of the module is collecting the light coming reflected from the ground, from the trees, from the clouds, from the environment that is surrounding the modules, as well as the same light that is going through and bouncing back.
Okay, so it's basically the same, except you either have a back sheet or you don't have a back sheet.
Correct. It's the same.
Okay.
Yeah.
And Glenn, we were talking about this earlier today, I think, where so as a racking manufacturer, this came up maybe 18 months ago with another panel manufacturer where we were looking at designing rails. So, the rails normally run along the back of the panels. And also we have a landscape rail, which means it runs along the frames or the top and the bottom. And that particular panel manufacturer showed me some test results that they'd come up with where it looked like the difference between having the rails running directly behind the cells or, having a landscape rail and being completely out of the way was pretty small as far as the output goes. That was their results on their testing. Has Canadian done any equivalent sort of testing or looked at that as something that...
Yes, we do a lot of research in that space. Of course, we are recommending... Of course, most of our research is done in the utility space, of course, because it's difficult to implement a bifacial system on your roof But of course, we are providing some recommendation, and the racking or the tracker manufacturer are spacing out the torque tube, so at least it needs to be at least 100 millimeters away from the back side of the module, in a way that doesn't affect too much the cells in the middle, as well as the clamping and the rails. They need to be on the side. We have to avoid to have rail in there running across the module. But also, if you see the frame of the bifacial module, it's a little bit different. It's got the flap shorter to avoid also shading.
Oh, I see. Yeah. Okay. So is it still framed, or
it's still framed?
It is still framed,
because the module is getting so big that once upon a time, probably 2 years ago, we had a frameless solution. But now with the module going like 2.2 meter long or 2.4 meter long, you can't have without frame.
Okay, cool. And Glenn, what are you excited about that's new technology-wise that the consumer is going to be loving this year?
Well, actually, solar trackers. So as you know, here at the Smart Energy Lab, we put in a tracking system. It's a 1P tracker and a 2P tracker. It's 1 panel wide or 2 panels wide. Yep. And we put a mixture of bifacial and mono perk on each of the trackers. So we got a direct comparison. What I was amazed to see was the bifacial's performance in lower radiance, i.e. fog. It was incredible. They really worked well because the fog reflects light in all directions.
Absolutely.
So, the other thing with tracking is it's really like switching on the power switch. 8:30 in the morning, the sun hits the panels, full power. All day long till the sun goes down. You don't have that big camel dromedary hump in the middle of the day, which is much better for certainly utilities selling into a market where the price is longer than just the peak of the day. But for here at the Smart Energy Lab, it means that we've got a kind of a guaranteed capacity for many, many hours. So yeah, I'm excited by bifacial, I'm excited by trackers, and they just look awesome when you watch them move, 1 degree every 5 minutes. It's a bit exciting. I sit out there watching the potatoes sprout.
Is it like a mindfulness exercise up here, Glenn? Checking the tracker.
Yeah, checking the tracker. That's right. Yeah, so that's one thing. Oh, look, I'm just generally excited by how affordable renewables have become. So the price of solar panels has astounded everyone. Like this, you look at the history, and back in the 70s when they were nearly $100 a watt US, and then they dropped suddenly, and everyone thought $20 a watt was amazingly cheap in the mid 70s. And what are we talking now? It's just tiny. I predict by 2030 it'll be negative, and you'll be paying people to take them out the door.
Yeah, that's a scary thought. I think I'll be redundant well and truly by then.
But it just means that the autonomous home is a reality. You can provide on your home all the energy the home needs. This average freestanding home in Australia. So that's a game changer. And with the advent of EVs, we're going to need a lot more generation. So yeah, that's what I'm excited by.
Okay. And how big's the tracker system you've got installed here?
67 kilowatts total. That's 2 trackers.
And are we at a point yet where, Clenergy does have a tracker system, but we don't sell it in Australia as yet, but we do sell it overseas. But it's obviously it only makes sense generally for utility scale projects in most cases. Are we at a point now, do you think, where small communities like this could potentially make use of that technology, and it would still have
I think so. This is probably a Vincenzo question, but I think the economics of the land use is what's happening now. It's using less land and producing more power. So you've got a limited amount of space, and you want to maximize the generation off that.
Yeah. Okay.
Well, yes, efficiency. We can see efficiency going with the 680 is already 22% efficiency. And then we have a new upcoming technology that probably Glenn will be glad to have here, like the HIT, and that will be to 24.
You're kidding. HIT's back.
Well, Canadian Solar, yes.
Sorry, what's HIT?
It's
HIT?
Heterojunction technology. So having silicon and amorphous in the middle. So it's
that's a good thing.
I think the patent was held by Sanyo initially.
Yes, for Panasonic Sanyo.
Panasonic Sanyo. Yeah, and then that patent expired, and then other people started doing it, but it was too expensive at the time.
The time was too expensive.
Yeah, I remember you were paying almost triple for 10 or 15% more production.
Yes, but Yeah, by June probably you would see a panel of the size of the old panels hitting 400 watt, and that's is still is a new
When you say the old panels, you mean like your 1 by 1.6?
1.1 by 1.7,
1.7.
let's say,
Yep.
400 watt.
Wow.
That's it's that big.
Yeah, it's exciting. I mean,
Yeah,
it's
exciting.
for the longest time, it was just so tiny, the incremental steps in the module side of the industry, but now it seems to be racing along in leaps and bounds. And I guess there's a bit of an arms race going on between the manufacturers in terms of technology and staying ahead, and I guess there's all the gamesmanship that goes on with that, and consolidation that's happening there as well. So if you're first with the technology, not so much first with the technology, but if you can make that technology that maybe has been commercialized by others but more cost effective and comes back to return on investment, LCOE, even residentially, then you're in a stronger position than your competitors. So there's everyone's jockeying for that, and the only way you get there is to keep your R&D spend and development going. So
just coming back to bifacial, can I ask a little bit of a Dorothy Dix question here, Vincenzo? So since the bifacial panel can produce from the front and the rear, are you always better off with bifacial?
No, that depends really from the albedo. Albedo is the ratio between the reflected radiation, solar radiation, and the global solar radiation. So it depends very much from your soil. So a dark soil, or let's say a black color, has a zero albedo, so almost zero reflection. The dark color is absorbing as much as the light and is not reflecting much. Instead, light colors, like to some extent like the snow, is reflecting probably 75%, which means the 0.75, 0.7 albedo, 0.8 albedo, which is a lot. And of course, depends when you're planning a big investment, you need to do an assessment, as we used to do with, or we still used to do with wind. Then you need to assess the source, the wind source. Now we predict that the solar market, at least for the utility scale, is going to go towards the bifacial. At least in Australia now, we are under construction probably more than half gigawatt of bifacial solar farms. So, and as we did for while the solar source is quite predictable with the software that are available, for the albedo, you need to do a long-term assessment. Otherwise, you make a mistake in your investment.
What about residential applications of bifacial?
We get this a lot, Vince, don't we? Why don't I use bifacial on my roof at home?
Yeah.
Yes. Well, that's a good question. I can probably tell of this funny story, a fun story of an installer that was complaining that he had installed next to each other on a roof a bifacial module and a monofacial module having the same power class, and the bifacial module was producing less power. And well, the reality is that he was installing the module, of course, close to the roof, and in that condition, because of the shade, the albedo was almost zero. Now,
so just stop there for a moment. So, because the backside of the module is so close to the roof, you get very little chance for reflectance.
Correct. So if you get your hand under a light source and you get closer and closer and closer and closer to the surface, you see that the shade, the area underneath are becoming darker and darker and darker and darker. So albedo was almost
so where
zero.
how far do we need to be here? Because I'm just wondering from, as a racking company, right?
Yeah, that's a good question. No, in US they are selling system in the commercial space where they lift the panel at least half a meter from the roof.
And they're still flush to the roof itself, or are they tilted?
They tilted, and they are offset a meter, at half a meter, no less than half a meter. So, and it might even work, because if you have an opportunity, if you think you're planning also to renovate your roof, you can install some white, covering, or even
white Colorbond roof.
Well, if we are advertising, but yes,
why not just chrome? Wouldn't that be?
Oh, even chrome? Yeah, no, absolutely. If
I think this is quite like councils won't let you have reflective roofs.
Yeah. You can. I'm not sure that whether the council will allow you the chrome, but anyway, white, definitely you are enhancing the albedo and the bifacial capacity. Anyway, back to the story. In this case, what happened is that the monofacial had the backsheet which was reflecting inside part of the radiation, and giving probably on a 400 watt module was giving a 10 watt more than the bifacial, because the light in the bifacial was going through the cell and got dispersed underneath and was not bouncing back. And
so the backsheet was doing the work of reflecting.
Yes.
Yeah.
However, if you install properly the bifacial and the same power class, and you got an albedo of at least, let's say, 20%, 0.2, then you can get a 7 or 8% more out of your product, which essentially is using the same cell. The additional cost of the bifacial is the additional glass at the back. I need to say also the bifacial has a lower degradation, because over time the module experience less also microfracture inside, because it's stiffer, because of the two glass they keep sealed, and they keep safe the cell for a longer time.
Wow, thanks for explaining that. I used to think albedo was how excited you felt about something, but no, that's great. It's actually about the reflectivity. So I think you've made a good point here. So in a nutshell, from what you've said, the internal reflection in a normal panel with a backsheet actually helps, certainly with PERC. And if you take away that backsheet, you have to have something else to reflect it.
Correct.
If it's not there, if you haven't got a white roof or a good albedo off the surface of the Earth, you're actually worse off.
Yeah, correct.
Okay.
And,
got it.
And installer understood, learned the lesson. But it was good that was listening, because a lot of installers sometimes are just complaining and say, "Oh, yes, your module is not working." Yeah. Well, they started like that, the conversation. "Oh, your bifacial is not working." I said, "Okay, let's see."
What are some common what are some common misconceptions that you guys get? I mean, Glenn, you
my favorite one is they work under a full moon.
Okay.
Solar system,
I've heard that one. Yeah.
And they'll swear.
So that's not true then.
And look, correct me if I'm wrong, but it's to do with the band gap energy of the cell, that there's just not enough energy in the photons reflected off a moon millions of miles away back onto Earth to cause an electron to be displaced from the outer shell.
To jump the gap.
And jump the gap, the band gap.
Okay.
So sorry, that was a little bit techy, but there you go.
No, I kind of feel like I sort of got that one then, actually.
Well,
maybe
probably one of the big problem that is, at least coming to us very often, and my regards you guys, is the clamping zone.
Yeah,
a lot of installer are misunderstanding the clamping zone, where they should install. And with the module, again, the problem is the module becoming bigger and bigger. Especially with the module becoming longer, you can no longer clamp the module on the short side, because the module, when it's subjected to the dynamic load of the wind, is opposing a very low mechanical resistance, and tends to
flex.
Flex and crack the cells.
Okay, so just moving on from that, then adding to that, so if they're bifacial, then they're only going to be in landscape, I guess.
It generally is for all modules, not only bifacial but also monofacial.
Yeah.
The modules are becoming longer. If you try to get, a ruler in your hand and you try to bend from the short side, is easier. That's the momentum of inertia than bending from the long side. That's more or less the same.
Yeah.
For module. With module becoming longer and longer, you can't no longer install clamp on the short side, but you need to install on the long side in a very specific location, which is on our manual.
Yeah. Yeah, I guess some of the challenges for the installers is, and even I myself, because from time to time we have to do analysis on this. So if we design a ground mount system, for example, and our ground mounts have girders that might be, let's say we standardize the product at 3.2 meters, the girder itself, then we have to figure out whenever we do a quotation, because the panels are getting larger and longer, a lot of times we have to go back to the installation guides and read them and just make sure that the rails are going to be able to sit in the correct location in order to meet the new clamping zones that have been put into place. And so, look, I can understand that it's not the easiest thing in the world to work out, but we did actually did a video with Costa and Longy from the Solar Cutters. We did and Ivan Ross Gomez, one of our head engineers, we actually did a video on YouTube about this topic, which actually addressed this. And one of the things that really came out of it that surprised me was, in a lot of cases, I found, like, I was always under the impression, just by eyeballing things and looking on crap solar and going, "Oh, that's horrible. There's no way that that's going to pass the installation manual test." But Ivan sort of said to me, "Look, in some cases, some of these systems will kind of fall under, the panel manufacturer's guidelines, which can be quite surprising, as long as it's like very low wind loads and very optimum conditions." But yeah, I can understand how that can be challenging for a lot of installers to work out.
Yeah, and I think I think of recent from what I'm hearing out there in installer land is that there's a lot more people getting audited and pulled up on it, not so much by inspectors. I think it's maybe, I don't know if it's a CER audit, but certainly it's been raised several times with us in recent months that they've been pinged on clamping zones. And
you have to be a brave person to be a solar installer these days. You're the most inspected industry in Australia, probably outside of a mine site.
Is that right?
Yeah, I mean, like you touched on, depending on what state you're on or in, you'll get an inspection from the distributor, who might, when they change you the meter, might actually inspect your signage. You get an inspection from an electrical inspector if you're in a state that has mandatory electrical inspection. You'll get a clean energy regulator inspection if you create STCs. So all those 3 times inspections kick you in. And then if you're in Victoria, Solar Victoria might well inspect you as well, and they've got their own sort of due diligence to cover because they're providing a rebate for customers. You might even have council inspections, or the customer might hire as post-installation inspection, because it is a valuable asset. So, you could be inspected 6 times.
It's incredible, isn't it? When you contrast it to, say, the air conditioning industry or something like that, where you see these split systems that
some of my best friends install
banged on the outside of a
couple
building.
Bit of wood, you're good.
They run AC over gutters and things. I mean, it's just like, there's obviously no inspection process going on there.
Canadian Solar not going to bring out an aircon unit anytime soon?
Don't think so.
Yeah. Not a mounting system either, right?
I think they just nixed that product after what I've said there. So.
I've started to see air conditioning guys use solar rail to mount their aircon.
Yeah, know, the big one is the non-penetration clamps, like the clip lock roof clamps.
Yep.
We've really been lazy with the marketing around that, apart from in the solar industry. But yeah, you show that to the aircon guys, and they're like, "This is fantastic!" It's such a game changer for them. So yeah, we are starting to see sales of those products into that space. Yeah, it's interesting. Okay, so one thing that you mentioned earlier, and this has been a bit of a hot topic, and I want to get your guys' opinion on this, right? So panels are getting cheaper and cheaper, more efficient, as you mentioned. What are we going to do with all the old panels?
We've got to recycle them. That's what we do now with any of our warranty product. We recycle it all through. Trying to think of the name of the company. I think it's Reclaim in South Australia that does it. But we're also doing a lot of work at the moment, just with another party to work on an app, so that if people are looking to upgrade their system or repower their system, that they can, go on this app. It's already well developed for things like, TVs and other consumer electronics, so that e-waste is properly looked after. And a lot of the big retailers like your Harvey Normans and your JB Hi-Fi's already have companies that handle that for them. And these companies are also interested in doing solar panels as well. The only point we've got to sort of work through is, naturally there's a cost, and who wants to bear the cost of that, recycling of those modules. But product stewardship is a huge thing, and it's a big thing with particularly the Victorian government at the moment. I know are looking at it, and they want industry to come up with some solutions. And won't be long before federally, I think it's a hot topic as well. But yeah.
Can I suggest some solutions?
Yeah, please.
Which I've even implemented here, which is use them as building material. So use old panels as a replacement for a non-habitable room roof, like a carport. It makes if you can seal the gaps, and there's ways of doing that, right from silicon to proper engineered solutions. You've now got a roof you'll never need to paint. It looks great. It'll last well beyond the warranty on the solar panel, and it's free.
It's like a radiation shield on your roof, isn't it? Really? It's fantastic.
So I've got pergolas here on the side of my house made of old solar panels. But equally, even if it's a underperforming solar panel, because a lot of panels are being replaced not because they don't work, but the customer wants a bigger system. And so you've actually got perfectly good panels going to e-waste, which could be repurposed in another way. So it could be a community facility that you put your old panels on, slap a microinverter on them, add them to the system.
Yeah, correct.
No, but there's certainly watch this space. There's a lot that's going to happen over the next 12 months in that area. So, and rightly so. I mean, we don't want to be, we have a clean green image in this industry, and we don't want to be responsible for contributing, to tons and tons and tons of landfill and that sort of thing.
Also because, probably 97% of the components of a solar panel are recyclable. So, that's the perfect component to recycle. Aluminium, glass, silicon.
Silver?
Silver, copper.
Just on silver.
Have you guys... it's tiny. You won't get probably more than...
we won't get wealthy on silver.
Well, you may do. Have you heard about what's going on with... have you been following the US stock market and the GameStop Wall Street Bets saga?
Yeah.
Apparently silver is the next target. By the time this gets out, I own quite a bit of silver myself, so hopefully, fingers crossed that
so Michael,
that one takes off.
Get ready for another price increase.
Just when I shorted my gold.
Actually, no, I shouldn't say that. No, take that back.
Don't buy silver. That's right. Well, you're listed on the New York Stock Exchange, so maybe you'll be the next Reddit reader's target.
Well, we can only hope. We better, as long as we get the mail early and we get in there.
You've got to be a target of one of the big hedge funds in order to get on the list, though. So
right.
You've got to be quite heavily shorted.
You've got to try and fail better. So you're obviously not doing a good job there.
But I mean, solar stocks in general have done pretty well, I think, over the last 12 months. So
definitely. I think that even that space, like a lot of investors are really bullish on the renewable space, energy in general. So yeah, that's great. When was Canadian Solar listed? Did it?
2006.
Okay. Wow.
Yeah.
2006. So when was it founded?
2001.
A long time.
Yeah.
Okay, I didn't realize that.
Yeah, it's one of the long-lasting company. Probably. It's one of the long-lasting company in the market after Jingli. I think Jingli is the oldest manufacturer since 1995. It's the second.
It's amazing how the fortunes of various solar companies have gone up and down over the years, but fortunately we're still in strong position, and
Yeah, well, it's been great chatting to you guys. Look, I really enjoyed the beers too, so thanks to Clenergy for those. And I've learned some stuff. That's what I like about these get-togethers and podcasts is, we talk stuff. We're all experts in different areas and we can share information. So thanks very much, Vincenzo, Michael and Sean.
Thank you. Pleasure.
Thank you.